Welcome to series of database management system video lectures. Today we will be discussing about unit 3 topic 8, that is recovery in database management system. Now, what do we mean by recovery? When any failure has been occurred to the database system, then we need to overcome from that failure. So whatever the data which has been affected, we should be able to get back all that previous data such that you can bring down the state to the database wherein it was like a normal or the earlier one. So let us look at what are the reasons for database failure. The first one is due to transaction failure. If multiple number of transactions are acting upon single data member and trying to modify the data value continuously with respect to various conflicts, whether it is a read conflict or write conflict, and without performing commit operation and performing cascading rollbacks, a series of cascading rollbacks, all this will lead to a lot of overhead, and that's how ultimately leaves the system to a state wherein all the data will be lost, right? And the second one would be the system failure, wherein all the components of the computer system may not have been working in a proper state, right? So in that case also, there will be loss of data while reading the data values from the user if there is any disconnectivity issue that has been occurred, or if the memory is running shortage of it also will have an impact upon the failure of the data. And while transferring, this third one is the disk failure, wherein when you are attempting to read the data from the hard disk storage to the physical RAM memory. While transferring the data, if we lose any sort of data items, that's how will not be reflected in the actual RAM memory, and the processor will be processing only that set of data items which are available in the RAM memory. So all these are the possibilities wherein there is a failure of the database management system. Now, how do we recover from that, from the failures? So we have two different techniques to recover from the database management system. The first one is log-based recovery. So what is log? A log is nothing but a file wherein it stores all the operations which are being performed in the database. So based upon that log file, you will be able to retrieve the information that at what point of time which transaction has modified the data, due to which there is a loss of the data. So we have subcategories, that is deferred database management, database modification, and the second one is immediate database modification. So let us look at the first one, that is deferred database modification. Now let us look at the deferred database modification. Now here we have two data members A and B, which are assigned as 100 and 200 values. Now we have a transaction wherein we are performing a read operation upon data member A. So when we are performing that, immediately in the log file, it updates each and every minute operation. So T1 is being started. Now the second operation is that you are reading the data member. So for T1 transaction, you are reading the value of a variable that was 200. So this is how in the log file the data is going to be updated. The second one is you are updating the value of A. So for T1 transaction, for A value, for A variable, 200 was updated, right? So that was done. And then write of A. So the same thing gets updated into the database. Okay, A as 200. Now read of B. So we are attempting B of 100. Okay. After reading, we are updating the value to B. So that is B comma 400. Okay. So now B is going to be modified as 400. And the same thing have to be updated into the database. So as we did not use the commit here, this values which have been updated will not be affected upon the database. So when it is going to be done, unless you don't issue a commit statement, the data values are never going to be updated in the database. So now before this commit, if there is any failure that has been occurred, so then whatever the changes that you have made to the database will not be reflected and it will be with original data values only. So to bring our system back, we will perform a rollback operation there. So while performing this rollback operation, you will undo all the operations which were done so far. So for doing this undo, you will be able to bring down the system back for retrieving your original data values. Now look at the other sequence of our transactions. So we are starting T1 transaction and then we are re-accessing to the data member A, which was 200, the updated values. Now the second one is you are accessing B variable, which was updated with 400. And now if a commit operation was used here, then all the data gets stored in the database with those new values. And then T2 is the second transaction and it is reading the data member variable to be 500, right? So this is how in deferred database management, deferred means late, it gets delayed. So unless there is no commit which has been used till that point of time, it will never perform modifications to the original database content. Instead, it will just have it in the local memory, only. The second technique is immediate database modification. So here, when we look at the previous example here, whenever you are performing the changes, let us modify the same thing here. Yes. So now, instead of default, let me go with immediate. So in this immediate, how the log file is going to be maintained here is nothing but the old value was 100 and the new value is 200. And then for B also, the old value was 200 and the new value, modified value is 400. So here both old and the new values are going to be maintained so that immediately the database changes are also going to be reflected. It will not wait till you issue a commit statement. Instead, immediately the changes are made into the actual database, which helps further for whenever there is a failure, you will be able to perform either redo or undo operations to retrieve the data back. Right? So this is immediate database modification technique. And the next one is checkpoint. So using checkpoint also, we will be able to bring our system into a recovery state. So now let us say that this is our timeline, and here you have a checkpoint 1, this is your checkpoint 2, and this is your checkpoint 3. Now this is a failure state, and this is another failure state, and this is another failure state. Now let us say that T1 transaction has started. T2 transaction has started here, right? Now let us look at checkpoint 1. By the time when you have checkpoint 1, how many transactions were involved? T1 and T2. So T1 was started and completed. Okay, started and completed. Whereas T2 has also started and completed. So now if there is a failure that has happened before checkpoint 1 itself, how many transactions were involved? Only T1 transaction, which has started but not yet ended. We are at this point. So in that case, we need to perform an undo operation to bring back the system into the original state. Okay. Now, if there is a checkpoint 2, then T3 is a transaction which has started here. T4 is a transaction which was come here. And T5 transaction and T6 transaction. Now look at checkpoint 2. By the time we reach to checkpoint 2, T1 transaction has completed, T2 transaction has completed, T3 transaction has completed, and T4 transaction has completed. But the failure point is at here. By that time, T4 was in the middle. So T1, T2, T3 can be undone. Okay. And T4 has to redo the operation because it was broken in the middle. Now look at checkpoint 3. By the time checkpoint 3 has reached, T1, T2, T3, T4, T5, and T6 has also completed, right? But the failure has happened at this point. So by then, T1, T2, T3, T4 have to be undo. Okay, it has to undo, and then T5 has to be read out because it has been broken at this point. So by looking at this checkpoints also, we will be able to bring back our database system into a consistent state with all the data which was lost earlier, right? So this will be the end of recovery in database management system.